to have Dr. Cassandra Olds with us tonight. The first time I heard her speak was at an agent update, and I knew from that moment that she would be a great presenter for producer meetings because she's very fun to listen to and she has a lot of great information that producers can utilize. So I knew I wanted to get her to come and speak on this topic. I just didn't know when, and then this opportunity came up, so I took advantage of that. But a little bit about her background. Dr. Olds earned a bachelor's degree in microbiology and biochemistry, a master's in veterinary science, and then went on to earn a PhD in microbiology. Her research focuses on understanding vector pathogen host interactions and managing the negative impacts that pests have on animal health and well-being. She now has a unique position with K-State as an assistant professor in the Department of Entomology and serves as the extension research entomologist with a veterinary specialty. So she's a wealth of knowledge when it comes to this topic. She'll be talking about effective pest management, how the creepies affect the crawlies. So take advantage of her being here tonight. Ask a ton of questions. We have a small group so we can have some discussion. You can either send questions to me privately or put them in the chat box. Otherwise, I'll open up the floor when she's done and we can ask questions. So the floor is all yours.
Great, thank you. And if anybody has a question while we're going along, feel free to interrupt me. We're not a big group, so it's not really gonna upset the flow of things. So let me share my screen, which I should be able to do. Okay. So the title of my talk is really how the creepies affect the crawlies. And so I am, like Heather mentioned, I'm an entomologist. So I primarily deal with things with 6 to 8 legs and how they affect our animals. And worms have no legs. So I really am going to talk about not only Helminth control, but how they interact and interplay with the ectoparasites that we have. So hopefully by the end of this talk that you're thinking about your livestock more as an ecosystem and less as an individual pest that needs to be controlled. So at the end of this, I also have my contact details in case you have any follow-up questions or things that you just want to chat about. I would always love to hear from you guys. I'm new to the state of Kansas. I love it already, but part of being new is getting to know people and finding out what the problems really are that FACE produces in the region. So feel free at any time to send me an email. So what we're going to be talking about, a little bit about nematode infestation. So we're not going to be talking about the liver flukes and the tapeworms. What we're really going to be talking about here is roundworms, and that's because they're the primary concern in terms of decreasing production. And then we're going to talk a bit about resistance to antihelmintics and how this happens and why it's such a big problem, and then also what we can do to slow this down and make sure that we can keep using the compounds that we have for as long as possible. And then we're going to use an example to talk about how external parasite control, so our ectoparasites, and internal endoparasite control really affect each other, and what you can do to be cognizant of this and how to make sure that when you're making choices, you're really thinking about the whole animal situation and all the different organisms that this the animal is encountered about. And although we're focusing on cattle right now, the concepts in this presentation hold true no matter which host organism or production system you're in, whether it's beef or sheep or goats or chickens. Integrated pest management is really a thing that we're trying to promote and have people think about, because it really is the way that we're going to have to go as resistance to pesticides is just increasing and increasing. Okay, so gastrointestinal nematode control in pastured cattle. So that's what we're going to be focusing on. So how do we see this? It's really hard to know that you have a problem until it becomes evident, and you can see this in reduced weight gains, poor feeding efficiency, feed conversion efficiency, diarrhea in calves you'll often see, and reduced milk production and reproductive inefficiency in cows. But these are really common symptoms, and you can have infection with different infectious agents that can really mimic these symptoms. And unfortunately, with worm burdens in cattle predominantly, you don't realize that you have a problem until that burden is really, really high. And then in our blood feeding nematodes, which I have some examples of later, you do see this characteristic bottle jaw. I have a little laser pointer here. So this is the bottle jaw that you see. But if you are not looking at blood feeding worms, you're not really going to see this. You're just going to basically see a skinny calf that maybe has a lot of diarrhea. So you really have to rely on your veterinarian to diagnose whether you have a problem. And how they do this is by doing fecal egg counts. And that can kind of estimate the population of worms or the burden that you have. The problem is that the number of eggs in the manure does not directly correlate to the number of worms in an individual. So we make the best guess approximation and then make a decision as to whether it is an infection that needs to really be treated. So we predominantly see the problem of these negative side effects, the symptoms of infection in younger animals, so younger than 2 to 3 years old. They typically have the highest worm burdens. And so they're mostly impacted by these internal roundworms. And as the animal grows older, it actually develops a natural immunity to these worms, so the immune response kicks in. And then, so what you have is older animals who can really, for the most part, self-manage their burdens. So they will have a low worm burden that is persistent, but it doesn't ever reach levels where you start seeing production losses, unless if the animal has something else going on, let's say it's nutrient stressed or it has a concurrent infection with something else. Then you can see the switch from an animal that's managing its infection to an animal that isn't. So even though adult animals can carry these worm burdens and not really have the symptoms of infection, they are the major contributor to pasture contamination. So they continuously shed these eggs, so they're reseeding the pasture with these nematode eggs. And that's something that we're going to come back to in a little while, and how this is actually sometimes a good thing. So it's just important to remember that even within your herd, different animals have different risks depending on their age and their overall level of thriftiness, and are they healthy, are they keeping their weight on, or are they slightly more poorly. So we talk about worms and we just throw this word around, and I really wanted to just put this slide here to highlight that there are multiple different species of worms, and they inhabit very specific areas of the animal. So you have worms that are only located in the abomasum, you have worms that are only located in the small intestine, and then worms who are only in the large intestine. So they really are specific to the area of host which they colonize. In addition to that, so not only are they site-specific, they're also specific in what they feed on. So you have mucosal browsers, you have tissue feeders, and then we also have the blood feeders. So we used to think, blood feeders aside, that's pretty self-explanatory. They actually directly feed on the animal's blood, and they result in anemia. And in high levels, this can be pretty damaging. But for the other two, the mucosal browsers and the tissue feeders, for a long time, we thought that the problem with worms was that they were stealing nutrients from the host. So the food is getting digested in the digestive system, and they're basically stealing it away from the host and using it for their own living and reproduction. But really what we know now is that that's not the case. The problem is that the damage that the worms cause from their presence, from disrupting the interaction with the digestive system, causes damage to the cell, the lining of the digestive system, which causes inflammation. And that inflammation also results in the pouring of blood and serum into the digestive system. And so you're losing blood proteins, you're losing blood. And also, importantly, it limits the uptake of nutrients from the digestive tract. So you're not only losing the protein that you have in the blood, and you're leaking serum into the digestive tract, which then gets excreted out, but also you're stopping the animal's ability to uptake those nutrients. Thankfully, as the animal gets older, like I said, they start to develop the antibodies that target these worms. And so they can actually, for the most part, older animals can manage this infection so that you don't have these negative side effects. And something that we often see in infectious disease is that it's not the pathogen itself that causes the problem, but it's the host immune response to that pathogen. And this is a great example of that. It's not the worms necessarily that are the problem, those who aren't blood feeders. It's actually their presence that causes a reaction from the animal, which then causes these symptoms. And historically, we've been pretty heavy-handed with the antihelmintics. We rely heavily on the administration of these broad-spectrum antihelmintics to control infections. So that's just the standard practice. You have worms, you give a drug. There's 3 classes of compounds that are widely available. And it's important to know that not all these compounds will work against all worm species. And even if they do target a specific worm species, they don't necessarily target multiple stages. So your consulting veterinarian will be able to tell you which worms you have based on the looking at the animal's manure, and then we'll be able to advise you as to which compound to use and for how long to treat the animal. So it's really good to have a good veterinarian who you trust and you can work with, who also knows what you have and have had historically, because that's going to enable you to make really good decisions. So with this heavy-handed approach to just using drugs whenever we have a problem, we really have excluded a large proportion of the parasite's life cycle. So what we've done is we've targeted solely this stage. Normally the adult stage, some drugs will target these L3 larvae. This is what it looks like in case you're interested. You can see here these little crypts that the worms are in the larval stage, which then they mature. This is where you get this inflammation and the irritation that then leads to the movement of blood into the stomach. And then this is what the adults then emerge from these little crypts, and then they mate, and then they secrete their eggs, and then these eggs pass out into the feces. If you think about this, this is a pretty protected stage. They have designed very, very, very specialized mechanisms to avoid the host immune response, so they can hide from the host. They're protected from the weather. They're kept at a constant temperature. Certain species, so for example, the species here, the Osterotegia, they can really go through a hibernation stage, so they will time when they're active and when they're not active to really make the most of the weather outside. So they really are adapted to hiding out in this mammalian host. For the most part, we don't do too much historically to this whole stage at the bottom where the animals, where the parasites are exposed to the environment. So this is really where they are the most susceptible. They're super, super susceptible to drying out. They're super susceptible to heat. Insects and worms cannot regulate their own body temperature, so they are strongly dependent on the external temperature of the environment. So any heat and any desiccation is really, really a nail in the coffin for them. And so we're going to talk about a bit later about different things that you could do to really reduce this. And if you can get rid of this population, you stop reinfection. So it's a really, really key place to stop the transmission cycle. And so I just put a picture here of what this worm actually looks like. They're really, really small, round worms. And so we talk about resistance to parasiticides, and this is not a phenomenon that is only in nematodes. You will have seen it with ectoparasites. It's a big problem for crop producers. So we're seeing this global trend of an increase in resistance to pesticides in general. Specifically in sheep and goats, this has been studied for a long time and has been well documented. And this is because the nematodes that infest sheep and goats are primarily those blood feeders that I had mentioned earlier. So what you see in sheep and goats, high worm numbers actually result in severe anemia and death. So it's easier to see when an animal has a high burden because you can check the anemia of you can check the eyelids, you can check the gums, but there's a higher sort of risk of high burdens because of the chance of the animal dying. This in contrast to cattle, where you just see predominantly decreased production gains. So it's harder to diagnose, and for the most part, we have not studied resistance in cattle as much, and also we've been sticking our head in the sand a little bit and saying, oh, no, it's not a problem. But it is now becoming very clear that it is a problem. I read a report that said that at one stage we were claiming that it wasn't a problem. New Zealand had already said that it was a problem. Brazil had said it was a problem. The rest of the world was saying it was a problem, and the United States was slightly later to the party. But now we've admitted, yes, we do have a problem. It's been identified across the country and against all 3 compound classes. And the thing with resistance is it never gets better, it only gets worse. So this is something that we are going to be facing for the foreseeable future. So understanding what resistance is and how it spreads is important, because when you understand it, you can be strategic in the way you target it. So it occurs through a mutation or a change in the genetic material. And changing in genetic material, this is a natural phenomenon that happens in all organisms. This is how we can have Great Danes and Wiener dogs. They all started from the same ancestor, but we selected for different features and bred with those features to get dogs that are very vastly different in the way they look. So the same thing happens in our invertebrate species, in that there is an advantage in one individual that then it spreads onto its progeny. And the reason why it spreads so quickly is 2 reasons. Invertebrates generally have very rapid generation time. So you can have multiple generations in a single season. Just think about your flies, how quickly you can go from an egg to a mature adult in 3 weeks. So in a period of from spring to fall, when they're most active, they can go through multiple generations. So they can really select for these advantages really quickly. The other thing is the super, super, super large number of offspring. So anytime an individual has a genetic advantage, it spreads it to all its offspring. So if you think a single hornfly can potentially have 500 offspring, if you've got a single hornfly that is now resistant to a pesticide, it will spread that resistance to all its 500 offspring, which will then spread it to their offspring. So you can see how this magnifies really, really quickly. And that is why pesticide resistance in worms and in insects and ticks is such a big problem. It's because of this explosion. And so I always get asked the question, can it ever be reversed? Theoretically, if you remove the pressure, so if you stop using the pesticide completely for enough time, it would be technically reversed, because there's no longer an advantage to having this mutation. And often these mutations come with a fitness cost to the insect itself. So it would then get rid of that mutation and pick up something else. However, it is unlikely that this happens because of the amount of time it would take. They've done some studies that have shown that even after 10 generations of withdrawing the pressure from the insecticide, you still have the resistance marker. That countered with the fact that even if you stop using these pesticides, you can always get reintroduction from a different area. So what we really have to do is be proactive in slowing the spread, instead of saying, oh, well, once we have it, maybe we'll try and figure it out. So the latter part of this talk is going to be talking about how we can really slow this process down. So this is just a graphic that I made to really illustrate what the problem is. So let's say you have a pastured cattle and you have hornflies, and you spray with your trusted pesticide, which has always worked. So we define resistance as a compound that used to work in controlling a population either fails to control it adequately or cannot control it at all. So normally you see it start off in its reduced efficiency, and then you get to the point where it doesn't control it at all. And that's because after you spray, let's say you have one individual who through just random chance has developed this mutation, everybody else dies except this single one with this new mutation, which either allows it to not be affected by the pesticide itself. So maybe the site that the pesticide targets has been altered in some way, or it also can have an increased ability to metabolize this pesticide so it is excreted sooner. So those are the 2 ways that we see resistance developing. And so this white fly, who then has this resistance gene, goes on to spread. And so you spray again, and it will kill the susceptible fly populations. But each time you spray, you're actually selecting for the survival of this population that now has this resistance marker. So it is just a snowball that just gets bigger and bigger. And what you have to do is stop using the product completely. So inadvertently, people might be doing things that select for resistance. So I'm going to go through some of the things that you might be doing that you don't realize that actually selects for this resistance. And hopefully you can start thinking about changes that you might be able to make to stop this from happening. So the biggest cause of resistance, and this is for any pesticide, is indiscriminate or overuse. So what this means is using a pesticide when you don't necessarily need to use it. So for example, you worm your cattle or your animals every single year because that's just what you've always done, and you use the same product. So not all animals need to be treated every single time. So just doing it because you've always done it, what it does is it provides the organism with a long time for it to develop these mutations and then spread them onto their progeny. One of the big things for antihelmintics specifically is the inconsistent performance of pour-on products and the role of licking. And this is for cattle. We use pour-on products for sheep, and it works pretty well, but they've got a completely different, they've got these hair fibers, so the product can get close to the skin, and then the animals don't lick as much and direct contact with the product. What we see in cattle is that they tend to lick each other and lick themselves, and so they remove the product from the skin and actually swallow it, and the product then, some of these products are not active through the oral digestion, and then it's basically useless. So we do not recommend the use of pour-on products for worm control in cattle. One of the big things is the use of antihelmintics with persistent activity. And what this means is when you give a drug that lasts for a long period of time. And so I'm not saying don't use these drugs. I'm just saying be aware that if you do use them, that you have this potential for resistance, and speak with your veterinarian and see if there's something else that you can add in to make sure that this doesn't happen. So this is one of these long-range drugs, long-release drugs. It's called long range, and it works. You can see here it works against multiple different worm species, which is really great. And it works for a long period of time, which theoretically sounds like a really good deal, right? You only need to give one injection and I could have coverage for 3 to 5 months. So on the right here, what we have is a figure that is actually the serum concentration of this drug. So what it is measuring how much drug you have in the animal's bloodstream over time. So it's on the same scale here, 0 to 150 days, 0 to 150 days, and 150 days is 5 months. So you see after injection, blood serum levels rise pretty significantly, but then they start to taper off. And this is really the area that we worry about. Even though the drug may be effective initially in this taper off period, what you're doing is you're giving a low level. So this, when you have a lower level of the compound, it actually starts selecting for resistance because you're not killing them outright. You're giving them enough exposure for them to develop these mutations, but not killing them. So this is why we really worry about the use of these persistent activity drugs, because of this tail end. So speak to your veterinarian, and it might be that you have to spike in with shorter acting compounds to make sure that you're not selecting for resistance in this tail end. And remember this product, because we're going to come back to it in a little bit. Lack of refugia. So remember I talked about our older animals who carry naturally lower burdens of worms, and they do quite fine with them. You don't see any problems with production. If you treat all your animals all the time, you remove the worms colonizing these animals who can tolerate them quite fine. And so you select for these resistant strains, and then you only have the resistant strains floating in the population. If you leave older animals who you know are doing quite well, they have a low worm burden, that you don't see them losing weight or anything like that, there's no selection pressure on those worms if you do not treat that animal at all. So sometimes the word refugia is kind of misconstrued, and you think that you've got to have animals that have high burdens who you just don't treat, and maybe they're doing poorly. What you really want is animals who can have a low worm burden, that they self-manage, that are doing really well. And so then you just don't treat these animals. And so what happens is they are seeding the pasture with worms that are susceptible to antibiotics. So when you have animals who are, let's say, younger, who naturally have higher burdens, or you have an animal who's maybe not as doing as well and might have a flare up. These are now select populations who are sensitive. So think of them as like little refuges for your good worms. Even though you don't want worms, these are good worms because they're not resistant. So you're giving them a place where they can be, so that you don't so they reseed the population of your pastures, which makes it a lot more controllable. Lack of effective quarantine treatments is a big one. We're now in the day and age where people get animals from multiple areas of the country, especially if you get your animals from down south. They have a lot bigger problem with worms than we do up here, and we've got more than up north. It comes down to climate. The warmer, the moister the environment is, the happier the worms are. So if you just buy animals that you've brought in, you firstly don't check what they have, and then you toss them in with animals you already have, what you're doing is you're basically seeding the pasture with these worms. So quarantine animals, treat them upon arrival, put them on a dry lot because the worms cannot survive on a dry lot. Once you're sure that they've cleared the infection, then they go out onto pasture. One of our big problems, and this isn't a problem that is selecting for resistance, but something that everybody needs to be aware of, we don't have any new products coming. They just recently developed a new product for use in sheep and goats, and it has not been licensed for use in cattle. So sheep and goats, they have kind of a bigger problem with resistance than we do. They now have a new product, but the moment you have a new product, even if we get a new product, the moment you start using it, you're starting the clock and you're saying, okay, how long is it till we get resistance to this product? So even if we did have a product, that's not going to solve the problem, because eventually we would get resistance to that product too. So there's nothing new on the horizon. So what we really, really need to do is make sure that we slow the resistance to the products we already have. So here is kind of an example, because we've been talking all about the creepies. We haven't been talking about the crawlies at all. So now I'm going to talk a little bit about how this looks like in the whole animal situation. So we have our animal on the left here, and let's say hypothetically she is infested with worms. She's got roundworms, she has horn flies, she has 2 different tick species, and let's say this animal is not the best doer in the world, and come winter time you do see that she has some lice populations. Her pasture mate over here also has a worm population. You can see she's a little bit fatter, maybe has a hornfly situation, doesn't have both tick species, only has the lone star tick, and it's a pretty healthy, robust animal. So come winter time, you don't see a problem with lice on this animal. So immediately you can see that not every animal will be colonized by the same parasites. There's a lot of host-to-host variation. We are learning more and more about these things every day, why these external parasites like certain animals and don't like other animals. Also, we're looking at how the resistance to these ectoparasites developed, similar to what we said with worms. As with age, the animal develops a natural resistance to parasitism, and can we harness this and use it for vaccines against these parasites. But for now, if you can just see that no 2 animals are the same, they might have different organisms affecting them, and also they'll have different burdens of these organisms. So any of you who have gone out into your pasture during the middle of hornfly season will know that not all animals have the same burdens. Some animals just have lower burdens. So our animal on the right, it's a really good doer, has low worm population, low fly population. The animal on the right. Animal on the left, in contrast, has a really high worm burden and maybe has a high hornfly problem. So what we might see is that the animal on the right then starts getting more hornflies, and you say, okay, well, my hornflies have reached the limit of 200 flies per animal, so maybe I want to go ahead and treat my herd of cattle. At this point, you may not even know that you have a worm problem, because all you're looking at is the external situation. You see your animal has a lot of hornflies, so you go ahead and you treat. And so what we normally do is we just chemicals again, directly remove the pest with chemical pesticides. Maybe you'll tolerate it for as long as possible. This is depending on the numbers, and each animal is slightly different. So we have this number of 200 flies per animal, but that's just an average. Each animal is going to respond differently to parasitism. And maybe if we're super good, we might alter the environment a little bit to make life harder for the pest. So what we have been recommending for, I want to say, the past 20 to 30 years is a rotation of pyrethroids and organophosphates. So they have always recommended 2 years of pyrethroids, 2 years of organophosphates. And we have now cut this down to 1 year of each, because it seems like 2 years with pyrethroids is too long and you're getting too much resistant building up. So what I want you to see here is that this information is on the internet. You can find out everything you need to know about the active ingredient in your products. And it really pays to know what you're using, because it helps you understand how you're breaking the cycle of resistance. So pyrethroids and organophosphates target the same compound. So they target a molecule called acetylcholine esterases. And this is really important in neural transmission. It's also important to know that mammals also have acetylcholine esterases. So all organisms have them. They're super, super important. Pyrethroids and organophosphates work slightly differently. And so what they do is, even though they target the same molecule, because of the different mechanism of action, they're grouped into different groups. And this is why you rotate between them. So if you use different products that are all pyrethroids, you're not rotating between these groups. So it's important to know which products you're buying and which groups they belong to. So you happily bounce between your pyrethroids and your organophosphates, but eventually you start seeing resistance to either one or both of them. So then you are told that, well, to break this, what you want to do is treat with a macrocyclic lactone. And so macrocyclic lactones are really interesting because they target a completely different molecule. So what they do is they activate glutamate-gated chloride channels. And it's not important to know what that is. The only important thing to know about that is mammals don't have glutamate-gated chloride channels. So it's really, really good because there's very low mammalian toxicity compared to the other compounds, which tend to affect mammals not as much as the insects. Remember, insects are much smaller, so any dose of the drug is going to be more effective against them. But just be aware that anytime that you are using a pyrethroid or an organophosphate, it is as toxic to our acetylcholine esterases as it is to an insect or a worm. The difference is we just have more of them, so you don't necessarily see the effects. But anytime you're handling these compounds, anytime you are breathing them in, you are damaging yourself. Don't have to worry about that as much with the macrocyclic lactones. And they're in a completely different group. So this sounds really great. So let's say you have your resistance, you choose your macrocyclic lactone. These animals are on pasture, so you want to go ahead and use that long range. But you haven't thought about your worm population. So inadvertently, by treating your hornfly population with this macrocyclic lactone, you could be inadvertently selecting for resistance in your worm population, which you didn't know you have. So knowing what you have is important, and how much of it you have is also important, because then you can start making decisions based on, okay, what is my biggest risk? What is going to cause the most damage? And your veterinarian, if you say, look, this is what I have, your veterinarian should be able to give you really good information on what your different treatment options are. One great thing about speaking to your local veterinarian is they should also know which organisms are present in which areas. So we don't have all the worm species all the time. They'll be able to tell you who you have and who you need to really be worried about, and who you can maybe let live and let live for a little while. So the last section is going to talk about integrated pest management. And this is really the way we need to go to stop the spread of resistance. What it is, it's a broad-based approach that integrates different aspects and practices for pest control. So what we're doing is we're moving away from relying solely on chemicals to control these pests. With pesticides, what we want to do is get rid of everybody. With integrated pest management, what you really want to do is keep the pest level below that injury level. So at what level of pests can you handle before you start having production losses or animals getting too infested? So knowing your levels are important, and knowing that not all animals will be treated in your population. So it's a little bit more intensive. It's easy just to treat everybody all the time, but what we're really doing in the long run, this is important for us to know that we can use these chemicals moving forward. It's environmentally safer, and unfortunately, this word environmentally safe has gotten a little bit of, in some areas, a bad reputation. what I mean by this is every time you're using these chemicals, you are causing toxicity to yourself, to the animals. We go on and eat these animals, to the environment itself. It's very dangerous for our beneficial organisms like our bees. So they are toxic compounds. Even though we don't necessarily die when we are exposed to them, they are still toxic. And so keeping them out of the environment is the best way forward for not only ourselves, but our children and the following generations that come. And importantly, by using them as sparingly as possible, what we're doing is we're really reducing that selective pressure. And so we're slowing the rate at which this resistance develops. And being familiar with pest reproduction helps. So knowing what you have is the first point. Then knowing how it reproduces and how often it reproduces is the next point. And anybody who ever wants to know anything more about the reproduction of these pests, feel free to reach out to me anytime. We're in the process of developing new fact sheets, which we're really excited about, that is giving you guys more information. Our current information is a little bit lackluster. So one of the things that we're making sure we've put on one of the most important things on our to-do list is making sure that we are giving you guys updated information that is relevant not only on the pests themselves, how they reproduce, and methods that you can use to control them. So what it looks like is a triangle. So you're going to invest the most amount of energy at the bottom part of the triangle, and then use the top level of the triangle as sparingly as possible. So what we're doing is you're starting with prevention, keeping up with prevention for as long as possible, and then you do intervention. And so we're going to go through some specific examples for our horn flies and for our worms that we used in our example. But what this really means when we're talking about cultural, we're looking at sanitation and habitat changes, making the environment not suitable for reproduction for this organism. Physical and mechanical, think about things like screens, traps, and rubbers. Biological, we talk about predators and parasites. So this is a little bit tricky when we're looking at specifically arthropod pests of animals. This works really well when you're looking at other agricultural sectors such as crop production, because there's a lot of predators of these insects that they can use. We don't really have that many, if any at all. So this isn't as applicable, but I have a slightly alternative interpretation of biological control, which I will share with you guys. The other thing to remember is if you ever do use biological control that is insect-based, you cannot use any pesticides. Because if you're spending money buying parasitoid wasps and then you go ahead and spray your animals, you're going to be killing off the wasps as well as your pests. And this means it's the same thing if you're looking at crop productions. Then when we're looking at the chemicals, what you really want to do is start off with what we call biorational chemicals. So these are repellents, oils, insect growth regulators. There is a misnomer out there that flies cannot get resistant to insect growth regulators. This is not correct. We are seeing resistance to insect growth regulators. How these regulators work is the animal consumes them orally, and then they're excreted out in the feces, and they actually, the larval stages of the flies, for example, will keep growing. However, they cannot go from a larval stage through the pupation into an adult. So you stop the adults. However, we're seeing resistance to them. Like all chemicals that we are using, this is only going to increase. However, they are better than the conventional pesticides, which kill on contact. So just be aware that insect growth regulators, we prefer you use them first, but they do still come with the risk of resistance building up. So now we're going to just give you some examples of different things we can use. So this is using our little example of our small little herd of cattle here, where we had the problems with horn flies and the undiagnosed problem of the worms. So starting off with cultural things, you want to do this as much as possible. Cultural practices really are all about removing the environment that the larval stages need to develop. So this could be effective quarantining. Like I said, when you bring new animals in, you can deworm them, but keep them on a dry padlock, because whatever they have that's getting shed out before that dewormer can take effect, they then die. These worms need to specifically have grass, and they can only go about 3 inches up the grass. So we'll come to that in a little second, but they need to have the grass to climb up the grass to then be taken in by the animal as it's grazing. So quarantining on dry lots is a great way to get rid of a worm population. Correct rotational grazing can be very, very efficient. Here is where it becomes important to know what you have and know the biology of the thing you have. So for example, horn flies, when it's warm, they can go through the entire egg to pupal, to emerging from a pupa in as little as 10 days. As the temperatures drop, that can take up to 3 weeks. So if you are in sort of the height of summer, it's pretty warm, and you're rotating every 5 days, you're not actually getting rid of your hornfly problem, because right at the time when your hornflies, your adult hornflies are emerging, you're bringing the cattle back on. So making sure that your survival time that it takes these organisms to go through their developmental stages is shorter than the amount of time that you're using, that you're keeping that patch of grazing area free of animals is important. You want them to all emerge from the dung and have nowhere to go. Very important is having good refugia. So again, adult animals, especially for the worm situation, adult animals who are carrying a low burden and are quite fine, do not treat those animals. Those are the best way to reseed with susceptible populations. Pasture burning is pretty effective in controlling horn flies. You can get a reduction just because the eggs are basically just incinerated. Co-grazing is something that I'm a strong proponent of. It's taking a while to catch on in the United States. I'm from South Africa. This is something that we do in Africa routinely. And the reason why co-grazing is so important is that it's very rare for different host species to share a pest organism. So for example, the worms that infest your cattle are not the same worms that infest sheep and goat. So you can really use them as almost a cleanup operation. So let's say you have a pasture that you've been grazing young animals, which you know have high worm burdens. What you can do is once those animals come off, you can graze sheep or goats. And what they're going to do is they're going to just gobble up all those larvae. Those larvae can't undergo their development cycle and they die. So it's a really great way to clean up a pasture. Grass length is important. I said they don't tend to migrate more than 3 inches up the grass stem. So if you don't graze your pastures too low, you can really reduce your risk of your animals being infected by worms. Another great one is grazing on cut crops. So once you've harvested your crop, you can then graze your animals on that, what's left of the plants. And this is really good because there weren't livestock on that area before. You don't have to worry about livestock being on it afterwards. So that's a great way to clean out your population, especially if you've got young animals that are getting slightly older and you want them to get rid of all those, shed all those eggs out on a pasture that you're not going to necessarily use again because you're just going to plant crops again the next year. So those are some things that would work both well for hornflies and for your worms. Physical and mechanical Bruce's traps are absolutely phenomenal. You can reduce your fly population by 50% to 90% by just using traps alone. So Bruce's traps, there's some schematics on the internet that you can do to design them. And basically what they are, they're traps and they have plastic that goes down. And as the animal walks through, the plastic scrapes along the back of the animal and basically dislodges those hornflies. They then go to the side of the trap and they can't escape and they die. Hornflies have to stay associated with their hosts. They feed 20 to 30 times a day. They die very quickly once they're off the host. They cannot escape these traps. Here, you're not using a single pesticide, especially if you put these traps in a way where animals pass through daily, say on the way to get water or something like that, or to a feeding station. It's one of the best ways to reduce your population without even having to invest too much because the animals are just going to go through on a daily basis. We spoke about dry lots. Those are pretty good for removing worm populations. One thing that I'm a great fan of that I'm hoping is going to catch on more and more is dung beetles. Dung beetles are incredibly efficient in removing manure. So they will remove manure from the cattle manure. And as we all know, cattle produce a lot of manure. And what they do is they bury it, and the hornflies and the larval worms cannot develop, and so they just die out. And so there's some statistics out there that you can reduce your burdens by up to 90% using these dung beetles. Unfortunately, the problem is that we've been using chemicals to control your external parasites and your internal parasites for so long that these have then contaminated the manure, and the dung beetles that we did have been killed off. Because the larvae are in the manure, there's residual chemicals in the manure, and the developing dung beetles just cannot survive. So hopefully, as we start using chemical pesticides less and less, our dung beetle populations can thrive again, and they just really are nature's wonder workers in terms of managing manure. So they really are great. I looked to see if there was a company that had started maybe rearing them so that you could buy them and release them into your pastures. Not yet. I suspect once the market grows, that might be a way that people might make money. I don't know. Maybe I will quit academia and go into raising dung beetles. We will see. Biological control. So I said this is slightly different when we're talking about pests of livestock. Biological, what I'm taking it to mean here in our context, because we don't have parasitoids, is really making sure that your animal has good nutrition, good supplementation, because this is a accepted fact now that animals who are in good health otherwise can resist the effects of parasitosis much, much, much better than animals who have got poor nutrition and who are stressed. An animal who is not getting good nutrition is not, immune responses are very, very costly in terms of energy. There's a reason why after you're stressed, you get sick. It's because your body has been expending so much energy in the stress component of our physiology. So producing that cortisol that keeps us going, the adrenaline, all of these things cost a lot of energy. And what means is that energy has to come from somewhere. So it's often taken away from the immune response. And so you have animals with compromised immune systems, which means that the effect of the parasitosis is even compounded. So an animal with a good immune system can withstand a higher parasite burden than an animal with a poor immune system. So one of the single best things you can do is ensuring good nutrition, high levels of protein, good supplementation. And this really allows your animals to be more resilient to the effects of parasitosis, be it external parasites or internal parasites. And then very, very, very lastly, if you have done all of these things and your levels still miraculously are too high, then you can hit them with the chemicals, obviously using them as sparingly as possible. But honestly, if you do all these intervention strategies, they may seem laborious, they may seem intensive, and honestly, they're not easy, but I can absolutely guarantee you that by doing these things, you're immediately going to reduce your population so that you don't have to use these pesticides as much as you do without having to do all of these interventions. And really importantly, this is the most important thing that we can do to slow the spread of resistance and make sure that we can use these chemicals for as long as possible. The pests aren't going anywhere. If anything, they're getting worse. So we really need to outsmart them and make sure that we're staying ahead of them by using all the tools in our arsenal to really make life as difficult for them as possible. I've said it before, know what you have and how much of it you have, because that's going to allow you to make key intervention strategies. And then talk with your consulting veterinarian about treatment options. Once you get to this point, they should be able to say, okay, you should use this product or don't use this product. Making sure you use the right product is really, really important. So we've changed our paradigm a little bit. So now our options of control have almost flipped. What we're going to do is we're going to directly remove the pest using non-chemical means. This is the simplest thing that we can do that really makes a big effort, and we're not even touching chemicals yet. We're going to alter the environment to make sure that life is hard for them, and also making sure that they cannot reproduce, removing those avenues for reproduction. We're going to bite the bullet and tolerate them at slightly lower levels. Sure, we would love to eradicate them all, but that is just not possible. So really knowing what your limits are, and this is going to vary depending on your individual animals, but knowing how much of parasitism you can get away with before it starts impacting your production. Try and let those levels get as high as you can before you start making any chemical interventions. And then lastly, when you've done all these things and you do still need to control your populations, only then are we advocating that you use these pesticides. So no matter when you use a pesticide, even if I have not convinced you that you need to start using integrated pest management, that's okay. Not everybody's going to want to do it. it's a fantastic thing, but you can take a horse to water, but you can't make it drink. If you are going to still use pesticides and use them heavily, please, please, please make sure you do the following things. Firstly, use the correct product. So that's knowing which organisms you have and knowing which products target them. We spoke initially about the different kinds of antihelmintics. Not all of those antihelmintics will work on each type of worm. So there is no point in you throwing money away and exposing other organisms to these pesticides if it's not even going to control the worm that you're looking at. Apply it to the correct class of animal. Not all animals can use all products, and the dosages vary. So make sure that you're using the correct product for the correct animal. Applied at the correct time. So worm populations will fluctuate. I mentioned before that there's the worms that have this hibernation stage. You really want to treat organisms when they're most active. You don't want to treat them during their hibernation stage. So there is no point in treating an animal just before the fall in terms of external parasites. Slightly different with internal parasites because they're less active during summer. So your worms that are on pasture for the certain species, they actually are less active during the dry summer or hot months because they desiccate really easily. So knowing when your populations fluctuate is really important, so you're applying your pesticides at the correct time. Use the correct dose. This is critical. Check weights of animals. So making sure that you're giving an animal a correct dose may be one of the most important things you want to do. Remember how we had the long range and we had that tailing off? Underdosing is the exact same thing as that tail end of that graph. What you're doing is you're exposing your parasites to a little bit of the pesticide, not enough to kill it, but just enough for it to develop that resistance. So make sure that you check individual weights if possible, have a good handle of the weight, make sure you give the correct dose, and make sure that you give it correctly. If half of it messes on the floor, it is not helping anybody. So make sure that the animal receives the correct dose. And then also check for efficiency. So you will know pretty quickly in terms of external parasites. If you use a product and you don't see any effect, then you know that it is not working and you need to swap products. Chemical classes, remember, it doesn't matter if you stay in the same chemical class. You want to swap from one chemical class to another. In terms of worms, this is a little bit harder because the worm eggs are not actually shed uniformly in the manure, so it's a little bit harder to check for efficiency. But what you want to do is you want to take a sample of the manure before treatment, have your veterinarian, they can do an egg count, and then you'll treat your animals with the product, and then you will take another sample and check your reduction. Anything less than 90% for an antihelmintic is considered no longer efficient. So you really don't have a big window to play with. So veterinarians can often do that for you. There are some places that will offer it as a commercial test. It's, you got to spend money to make money. Knowing what you have in terms of parasites and what your loads are mean that you can make educated decisions in terms of what you're going to do to treat them. So very important, any pesticide, and this even transfers into crop production. Similar things apply, making sure that you have the right pesticide, making sure that you're applying it correctly, and making sure that you're checking routinely whether it is actually efficient or not. So I think I've got time for questions. These are my details if you want to get hold of me. I'm also on the K-State website if you have any further questions. I am going to stop sharing because I can't see if there's any other questions, but if you need me to, I can also just put this up at the end of our talk and you can take it down. I need to get my cursor back though. Okay.
Do we have any questions for Dr. Olds?
Yeah, I had one come in. They said wasps work great for fly control around the home place where the cattle are more confined in dry lot situations.
Yeah.
They're wondering what your thoughts were on using them in like a pasture situation without the concentration, how effective they are there.
Yeah, so your parasitoid wasps what they do is they'll find the pupa, the fly pupa, and they will lay their egg into the pupa, and then the developing parasitoid larvae develops in the pupa. So they can be really, really effective in a confined cattle operation, because you release these wasps, all the pupa are around, and they can do it. They're not going to be effective in a pasture type situation, because your distance between your pupa is just too high. So I wouldn't recommend them at all in a pasture situation. Something also important to remember, horn flies are so adapted to cattle that they can actually not grow in manure that's not bovine in origin. That is how adapted they are to cattle. They cannot survive, they will not pupate in horse manure. So they just love them cows. So, they really are so strongly associated to their cattle host. So if you can remove that manure, they will not find another place to breed. Houseflies, when we talk about houseflies, pretty non-selective. They'll breed in anything. Stable flies is another one. If you've got any sort of decaying vegetative matter, stable flies will breed in that. But horn flies, thankfully, they are so specific that they will only lay their eggs in fresh manure. It can't be dry manure. Houseflies will do quite fine in dry manure, but a horn fly has to have fresh manure. So in terms of rotating your grazing, if you take them away from that manure for long enough and those paddies dry out, that's that population gone. They don't have any cattle to jump onto. They're not going to jump onto sheep. They're very rarely, in a pinch, they might try and feed off a horse. But if you've only got horses in that area, even if it feeds off that horse and there's only horse manure around, you kill the population. So by just removing the host from that area for a certain period of time, you can actually get rid of a large portion of the population.
Okay, thank you.
Just a follow-up on that question. So if somebody is using rotational grazing, how long should their rotations be before they come back to that pasture so you don't reinfect?
That I actually, unfortunately, can't answer. I wish I could give you a time frame, but I can't, because of the fact that these invertebrates, anything that isn't a mammal like us, flies, ticks, worms, all of them, their ability to reproduce and their developmental time is so strongly correlated with external temperatures that it varies. So like I said, for example, a hornfly, peak of summer, 10 days from egg to being a mature adult. As it gets colder, because they're relying on the external temperature, so all enzymatic processes do best at about a 37-degree temperature. That's why we are the temperature we have. You slow that down, all your enzymatic processes slow down, so it takes longer to develop. So think about it as a car who's cold. It's kind of sluggish and it takes longer. The same thing for these pests. If it's colder, it takes them longer to go through that developmental stage. So if it's super cold outside, it could take 2 weeks, could take 3 weeks. So it really, really depends on the temperature. So, I mean, a good way to do this would be to just, if you just drew a curve, maximum, warm temperatures, let's say it's 90s outside, 10 days, and then cold temperatures, let's say, 60s, 70s, that's going to take closer to 3 weeks. So anything between there, if you just draw a line between those, you should be able to approximate what that is. Now, the worms are a little bit tricky because each worm species has its own different timing. And so that's why it's important to speak to your veterinarian, because he'll be able to identify what worms you have, and he should be able to tell you the developmental times. And so then you can start to think about, okay, I have this, I have this, I have this. This one takes this long. This one's taking this long. This one's taking this long. What should I do? So there's no sort of one size fits all. And that's why I say knowing what you have is important. And the warmer it is, the sooner you can rotate. The colder it is, the longer you have to wait, is, I guess, the rule of thumb.
That's interesting. I would have thought it was reversed, but that makes sense.
Yeah.
Do we have any other questions for Dr. Olds? I had a question. You mentioned overuse of anthelmintics. and that not all animals should be treated every single time. So how do we decide which animals should be treated? So who's the most susceptible? Should we focus on calves? Should we focus on stressed animals? What should we do?
Yeah, so it's hard, especially when you have high animal numbers. You know, if you've only got 5 animals, it's really easy to tell who's who and keep a track of that. But when you've got high numbers, it gets a little bit more tricky. So I would say the general rule of thumb is older animals, so your cows. In a cow-calf operation, cows predominantly going to be fine, unless there is an animal who is otherwise stressed or diseased. And you should be able to see pretty quickly if an animal starts losing condition. And then you can check, okay, does it have worms? What's the burden like? Does it have something else? Does it have an anaplasmosis infection? Does it have too many horn flies? What is causing this animal to be the way that it is? But for the most part, I would say adult cows should be fine to leave untreated unless you have super high worm burdens or super resistant populations. Younger animals for sure need to be treated. So younger animals, their immune system is not quite up and running. It's just like kids. Now kids get sick all the time. That immune system is developing. So as the animal matures, it starts developing this broader range of things it can target. So as it matures, you have to worry about these worm burdens less and less. And so they'll sort of get to the age where they self-modulate. But younger animals specifically need to have a little bit more help, especially if you're looking at a situation where you're trying to get as much production value out of an animal over a short period of time. That animal is more of a candidate for being treated than an animal that you're going to hold on to for a long time. Because let's say it's an animal that you're going to keep for, you know, it's most of its lifetime. You don't have to worry necessarily about production as much because you're going to keep the animal in the long run. So you maybe want to not treat that animal unless it's really having problems, because you want to keep that susceptible population and allow that animal time to develop. If you're having more turnover, this is an animal that you need to get as big as possible in a short period of time as possible, then you'd want to treat that animal, because high worm burdens will have production losses. So it depends on the individual animal, but you want to treat as few animals as possible. So anybody who you're keeping for a long time, anybody who is slightly older probably doesn't need to be treated. Younger animals for sure need to be treated, or animals that you're not intending to keep and you really need to beef them up fast.
Awesome. Do we have any other questions for Dr. Olds before we let her go? Well, we really appreciate you coming on tonight.
No problem. And what I'm going to do is I'll put my email here in the chat so that everybody has it.
Oh,
okay.
Perfect.
Okay. There it is.
Awesome. And you gave us a lot of great information. You definitely changed my perspective on things that I just didn't know. So we really appreciate you spending the time and come and talk to us. So thank you, Dr. Olds. I am going to put a survey link in the chat box. So if you all had time, please visit that link. It allows us to know what we're doing well and what we could work on. It also provides you an opportunity to tell us what you would like to see come to the Northwest region in terms of livestock programming. So we hope you go over to that link, take that quick survey. That way we know what we're doing well and what we could work on. So that being said, I think we're all done with questions. And again, we thank you for coming on and sharing your knowledge with us.
Thank you. It was fun. Awesome.
Well, we're going to take off now. And thanks for everyone participating in the Fence Line series. This is the last Zoom. So thanks everyone and have a good night.
Bye-bye.